Welcome everyone. Thanks to be here. Today we're going to talk about how to craft a Seccomp profile within test pipeline. But first of all, let me introduce myself. So my name is Alessio Greggi. I work as a software engineer at SUSE. As a second job, I like to say that I'm a cat food opener for my cat Gino, and I'm also an enthusiastic reader and hiker. You can find me on GitHub and Twitter with the following account and the following avatar. Don't know if you know the game Machinarium. So before start the talk, the juicy part, I would give you some introduction about a few concepts that will facilitate the understanding of the talk. So first thing is about code coverage. So the code coverage is basically a metric that can help you understand more about how many parts of your code are tested. And when we say tested, we mean that the code is effectively doing what is expected to do. It's a percentage, is expressed as a percentage, and it's mostly used when we're writing a unit test, but not only. About Go, the first time was introduced in the version 1.2 for the unit test, and after almost 10 years, the story continued with the version 1.20 with the introduction for the integration test. So this sensitively increased the coverage percentage of our project. And that's an example of how we can do the profiling for the coverage and render the result in an HTML page. The other concept is about Seccomp. So Seccomp, it's a kind of a Linux security feature that basically allows you to block certain syscall based on the profile that you can craft. So the profile, it's basically a list of syscall that you can deny or allow. And one important thing is that it is extensively used in the Kubernetes ecosystem with the default Seccomp profile that can be enabled with the feature flags. So this basically is a default profile with several syscalls that are considered deprecated or vulnerable, and you can use it. So let's start from the main idea that I had. So it was my kind of a secret dream. So having a pipeline that was able to create this Seccomp profile at the end of the run, and having this artifact, this Seccomp profile as artifact, inject the artifact directly into the node that we're hosting our application. So we can basically call it from the security context for the Seccomp profile. So let's see how I did it. So the first thing was about the elements that I had to deal with. So first thing was the integration test. So with the integration test, I basically thought to have a build binary and several scripts that was running this binary to check if the binary was doing the right thing and was behave in the right way. And yeah, the idea was to use this binary and use some tool for tracing, like strace or perf. So in this way, we can basically collect all the syscalls from the unit test. But the main thought that I had was that this was not enough. So I thought to put in place also the unit test. And it's a bit more complicated, since the thought that I had at the beginning was not applicable, since we cannot use basically strace go test, since we are going to collect all the rest of the syscalls that are not related to our code, specifically to our function. So the first thing that I thought was to split the things, since GoTests is basically compiling and run the test binary all at once. So by compiling it using GoTest-C, we can have the test binary separated by the GoTest run. But also in this case, strace doesn't work well because we are collecting other syscall not related to the function that we are trying to trace. Like for example, if we are reading a file from outside for, I don't know, test cases and so on, this doesn't work well. So in order to avoid of catching this kind of noise, I tried to think to a solution, and the solution was this side project that is named Harpoon. You can find it on GitHub, and it's basically a program that uses eBPF with a trace point and a uprobe with a uret probe. The uprobe and the uret probe are placed on the function that we want to trace. This uprobe and uret probe emits a kind of event when the function starts the execution and stops the execution. So during this time, with the trace point, we can trace all the syscalls that have been executed by the function, the specific function itself. Another important thing is that I'm using Aqua Security libbpf Go library that is a kind of binding of the libbpf Go, the libbpf library. So yeah, that's basically how does it work. So we have the uprobe and the uret probe that are placed to the main.doSomething function. The main.doSomething function is the symbol name of the function within the ELF file, so within the binary. And the trace point is basically listening for the sysenter event that is basically giving us the name of the syscalls that are going to be executed. So one example to run Harpoon is to use a Harpoon capture -f to specify the symbol name of the function, followed by the command that we want to run. So the command will basically run this function during the execution. And another interesting thing is that we can also tracing the whole execution of the program by specifying the symbol name main.main. That is basically the symbol name of main, the main function. So it's the demo time. Hopefully this will work. Just a second. Okay, so the idea was to give you an example of how we can trace this function. It's a useless function just for the demo. And it's using the net.interface by name function from the standard library. So from this side, we can use a Harpoon to capture the function. But before this, I want to show you how we can do this thing using objdump. Okay. So with objdump, we can search for the symbol of the function that we are searching. So interface exists. No. Okay, here it is. So this is the symbol name of the function that we want to trace. So we have to specify this symbol. Sorry. Yeah. So basically, this is the symbol name of the function that we want to trace, and we can check this thing within the binary. So that said, we can trace the symbol name of the function and follow it by the command that will execute this function during the run. Yeah, okay. So the function is basically calling the socket non-sleep bind send to get sock name syscalls during the run. And yeah, that's more or less how does it work. We can have also, with Harpoon, there are also other commands, like, for example, the analyze command and the hunt command that are basically taught for to run, to trace the syscalls from the unit test. So this basically does the same for the capture, but only for related to the unit test. So let's get back. Okay, so the recipe. How I get all the things together, put it together, and achieve the result. So first thing is obviously Harpoon that you can find me on. That you can find on GitHub. The other project of mine, it's just an example, but it's it was full of tests, so it was a good environment to test Harpoon. It's forwardctl. It's a useless tool just for managing the IP tables forwards. And as I say, there are several tests. It's covered with a huge percentage, so it was really helpful for validate Harpoon. And another part of the recipe, it's test script. Test script is a kind of suite to run tests, especially integration tests, and gives you the ability to write a kind of script that looks like the following. You have some built-in, like, for example, the exec. So exec allows you to run the binary that you want to test. So you are basically listing all the commands of your CLI that want to test. There are also other built-in, like standard out, that you can basically check if the standard output is the one expected. But the really nice thing is that you can define your own built-in, your own command. Like, for example, I did in this example. So forward exist is basically checking that after the execution of forwardctl, the forward exists in the system. So starting from there, that's the pipeline. How does it look? I basically run the integration test and the unit test separately, and after the jobs pass, I go ahead with the tracing, and finally I basically collect all the metadata that Harpoon generated. I put it together, and in the final job with the build Seccomp profile, I basically build the Seccomp profile. So let's do a bit in deeper. So for trace integration test, which is this one, I basically install Harpoon. I run the test script suite, and I basically wrapped the exec command that is the one that I showed you before with another one that is exec cmd, that is basically a wrap around Harpoon, as you can see there, with the main main function, symbol function. So I'm basically tracing all the syscall executed by the command that I'm going to run. And this basically looks like this. So exec cmd forward create -d blah, blah, blah. For the trace unit test, I basically do the same with install Harpoon and Harpoon analyze and Harpoon build, that are the command related to the unit test. And finally, after both the jobs are passed, I basically collect all the metadata generated in the previous jobs. I put it all together and generate the second profile and provide it as an artifact. So that's the result for, especially for forwardctl. As you can see, there are the syscalls that we checked previously with a few others. And yeah, that's it. So as a recap, we have several ways to improve our security of our project. So, I mean, let's do it. So thanks for your attention.